Hello, we here now discuss last type of that electrolyte concentration cells, that is electrolyte concentration cells with transference. We already explained what is this difference between cells, that is electrolyte concentration cells with transference and without transference. Here that EMF equations, cell reactions, that example of that electrolyte concentration cell we discussed for electrolyte concentration cells without transference. When cell is with transference, that two electrolyte solutions are in contact with each other. In without transference cell, that two solutions are placed in separate beakers and connected by a salt bridge. But that salt bridge is there even though uh, that salt bridge is there, but then also there is no direct passage of ions from one solution to another solution, and therefore that two solutions are not in direct contact with each other. And when salt bridge is there, that is considered as an example of cells without transference. No transfer of ions, direct ion transfer is possible in that case. But when solutions are placed, both solutions are placed, both electrolyte solutions are placed in same beaker without mixing and separated by only semi-permeable membrane. That is, if large beaker type vessel, half the vessel is filled with that beaker is divided into horizontally two parts. There is semi-permeable membrane is placed horizontally in that beaker, and which divides that beaker into two parts. In one half part, A1 activity solution is placed, in another half A2 activity solution is placed. That two solutions are in direct contact with each other because there is only semi-permeable membrane is semi-permeable membrane between that two solutions only. Therefore, ions can migrate from one solution to another solution because semi-permeable membrane allows passage of ions. In this case, the two solutions are considered as in contact with each other and cell with transference. If we consider EMF of this cell, then EMF generated is because of two processes. First thing is that EMF generated because of oxidation and reduction at anode and cathode respectively. That is because of the electrode reactions. And second thing is that additional to this electrode processes, there is movement or passage of ions across the membrane, that is from one solution to another solution. And this also leads to development of voltage, or that EMF development, that is considered as a EJ, which is small potential developed because of passage of that ions from one solution to another solution, that is higher to lower concentration solution. This generated potential is known as liquid junction potential, that is EJ. Therefore, if cell is with transference, then that is equal to, that potential is equal to E cathode minus E anode, that is EMF generated because of electrode processes, plus junction potential EJ. Therefore, if cell is with transference, that ET is nothing but EMF of cell with transference, and EWT, EMF of cell without transference. Hence here cell is, if without transference, with transference, EMF of cell with transference, that is ET, is equal to EMF of cell without transference plus EJ. Here EJ in this type of cells, EJ is additional potential developed. Here we explain first type of this cell, that is electrolyte concentration cells with transference reversible to cations. Consider example: platinum H2 gas, 1 atmospheric pressure, dipped in HCl having activity A1. Same HCl solution is in contact with each other, in contact with another HCl solution having activity A2. The two solutions are separated by semi-permeable membrane, which represent by single line only, and therefore there is passage of ions from one solution to another. And in another side solution, that is in A2 solution, HCl having activity A2, in that solution platinum hydrogen gas electrode is placed. Then cell reactions at anode oxidation, which here shown as oxidation takes place, shown as half H2 gas is converted to H plus plus 1 electron. That H2 gas is here, at oxidation takes place at left hand side here, and here hydrogen gas bubbled with pressure P1, both pressure is same here, and that H2 gas is here oxidizes as half H2 gas, oxidizes as and converted to H plus plus 1 electron. That generated H plus ions are um, are coming in HCl having concentration A1 having activity A1, and in another reduction takes place, H plus ions from solution having activity A2 accept 1 electron and that convert to half H2 gas. Net cell reaction is H plus having activity A2 is converted to H plus having activity A1. Applying this is electrode processes. Addition to this, we know that there is material transfer. How that material transfer takes place here? We know that at left hand side oxidation takes place, and here H plus ion concentration increases, while at right hand side reduction takes place, and due to reduction H plus ion concentration decreases. H plus ion concentration decreases, and therefore from H and Cl there is neutralization. A positive charge of H is cancelled by Cl minus ion, negative charge of Cl. But neutralization of H plus is takes place because of reduction also. Many H plus ions neutralizes and form H2 gas due to reduction. And therefore Cl minus ions, many Cl minus ions remains unneutralized as it is, and therefore at this size Cl minus concentration increases, and that migrates through that membrane from solution having activity A2 to solution having activity A1. Here H plus concentration is increases, and therefore that H plus migrated from solution having activity A1 to solution having activity A2. And because of that passage, here same passage is shown here in a reaction form. T minus Cl minus ions having activity A2 is migrated towards T minus Cl minus having activity A1, and 1 minus T minus of H plus ions having activity A1 is converted to 1 minus T minus H plus having concentration A2. Here we know that T plus plus T minus is equal to 1. Transference number of cation plus transference number of anion is always equal to 1. Therefore, T plus is equal to 1 minus T minus. Instead of written T plus here, that transference number of cation is considered as a 1 minus T minus, which is nothing but same as a T plus, small t base 2 plus. Then net EMF is calculated, that is the calculated by adding equation 1, equation 2 and equation 3. That is overall process is sum of equation 1, 2 and 3. Then consider writes LHS and RHS of all these three equations and make the sum, and making sum and by cancelling common factors we got equation as a T minus HCl having concentration A2 is equilibrium with T minus HCl having concentration A1. This is net cell reaction. Then applying next equation, E cell is equal to E standard cell minus 2.303 RT upon NF log of A1 upon A2 bracket raised to T minus. Then by apply that we know that N is 1, E standard cell is 0, 2.303 RT upon F is 0.0591. By considering all that terms, above equation become E cell is equal to T minus into 0.0591 into log of A2 upon A1. Then if we consider A2 and A1 for univalent electrolyte, that A1 is equal to M2 gamma 2, M2 square gamma 2 square. A1 is equal to M1 square into gamma 1 square. Then that equation become E cell is equal to T minus into 0.0591 into log of M2 gamma 2 upon M1 gamma 1 bracket raised to 2. Then that equation become then E cell is equal to 2T minus into 0.0591 into log of M2 gamma 2 upon M1 gamma 1. Then for unibivalent, that equation activity is nothing but 4 into m cube gamma cube. Then that for that purpose equation For unibivalent equation become ECl is equal to 3t minus into 0.0591 into log of m2 gamma 2 upon m1 gamma 1. This is equation, final equation, using which we can calculate EMF of electrolyte concentration cell with transference reversible to cations. Remember. Thank you.